Hello everyone and welcome to the notes for lesson 10.2. You should have gotten this worksheet on block day, sorry about that, and the intention was to post this video for you to watch at home before block day, but that just didn't work out with the plans with me being gone, so you're watching this in class now on Friday. And so before you get started, hopefully this is what you have done. You have hopefully filled in all the vocabulary in these spots that I've highlighted. The examples you don't have to do yet, that's what the video is going to focus on. But we are talking about measuring angles and arcs, so you should have a definition for central angle, and I'll add some to that here in just a minute. And then this place that I've highlighted here, you should have information already written down there, and I'll talk about that to make sure you have that. And then on the back, there's a couple other things that I wanted to point out. You need to have definitions for congruent arcs and adjacent arcs. And then this, there's nothing really to write down, but I will talk about this as part of the vocabulary before we go on to this last set of examples. All right? So if you don't have those written down, you can try and get these copied down as we go, but I am going to go ahead and assume that you did that part so that we can do these examples. So let's talk about this quickly. We're talking about measuring angles and arcs, and so we need to talk about what some of these things are. A central angle is the first thing we need to understand. A central angle is an angle with a vertex at the center and then these sides containing the radii. So basically you take a radius this way, that creates what we call a central angle. Vertex is at the center B. And we would say angle ABC is a central angle. And then if I were to add up all the central angles in one circle, I would have to get 360 degrees. And so that helps you understand that central angles are measured in degrees. Making a complete circle would be 360 degrees. So in our first example, we want to find the value of each of these unknown central angles. So we have a 145 degree angle here, a 165 degree angle here, and then x degrees. So remember, all three of these must add up to 360 degrees. Okay, so we just add these, and we get that this x plus a total of 310 degrees would equal the total of 360 degrees. So we just take that away from both sides. And 360 minus that 310 is 50 degrees. Okay. Part B, very similar. Now I don't write both of these central angle measures in, but I do put this little box in the corner. You should recognize that means that is 90 degrees. So 90 plus 120 plus x would equal 360. Or x plus 210 degrees equals 360. So we subtract 210 from both sides. And x is 150 degrees, for example B. Okay, and it gets a little more complex as we add algebraic expressions in. And I'll try and zoom in a little bit so we can see this. The print's a little bit small, sorry about that. So we have another set of central angles, and there's a lot of things I want you to remember about this, things that we remember from previous lessons. Things like a linear pair of angles adding up to 180 degrees and vertical angles being congruent. Since BE and AD are diameters, they're intersecting segments, that creates vertical angles here and here. So this is also 75 degrees. So we actually know more information than it looks like. And then also, these two would add up to an angle that is a vertical angle with this one. Now I don't want to think about that as much as figuring out what that angle measure is. Remember that this angle and this angle create a linear pair. So the measure of the angle here on this side of Z is 180 minus 75. Because these would add up to that full half circle, which would be 75 or 180 degrees. 180 minus 75 is 105 degrees. So this angle is 105 degrees. That creates a vertical angle with this angle, the sum of these two together. So this is what tells me 5x minus 5 and 7x plus 2 have to add up to a total of 105 degrees, because it's a vertical angle combination with those. So that's how I write that equation. 5x minus 5 plus 7x plus 2 equals 105. And so we combine like terms. 5x and 7x makes 12x. Negative 5 plus 2 is minus 3. Then we start to solve for x by adding 3 to both sides. 105 plus 3 is 108. And then we divide by 12 on both sides. And we get that x equals 9. And that's what we were supposed to do, is find the value of x. Okay, so we can use these central angle measures to find missing pieces like that. All right, and that creates the next part of our lesson. When I take a central angle, the places where that central angle intersects the circle create a part of the circle called an arc. An arc is a portion of a circle that's defined by two endpoints. We have an endpoint R and an endpoint P of this arc. We actually have two different arcs created by these two endpoints. Okay, arcs are measured in degrees, okay, because they're going to have the same measure as their corresponding central angle. And so we measure an arc in degrees. And that you may not have found in the text necessarily, so make sure you have that written down. We measure arcs in degrees. And then, like I said, we actually have two arcs that have these two endpoints. We have what's called a minor arc and a major arc. Minor meaning smaller, major meaning larger. A minor arc is the shortest arc connecting the two endpoints, and the major is the longest. Now we label these a little bit differently. This you may not have picked up on. We label a minor arc with the two endpoints and this arc symbol above it, kind of like a segment line, only we curve it to make it look like an arc. And the major arc uses the same two endpoints, but to distinguish it from the minor arc, we add in a third point to show that we go from P through T to R to talk about the major arc. And then a semicircle is an arc, but it's an arc with endpoints that lie on a diameter. And so you'll notice that I've written these here. A minor arc will always measure less than 180 degrees. A major arc will measure greater than 180 degrees. And a semicircle will equal 180 degrees. Okay, make sure you have that information down. If you need to ask the sub to pause the video, this would be a good time to do that, to get caught up. Otherwise, we are going to move on to talking about how to identify the types of arcs from a given example. All right, let's take a look at this next example. We want to identify each type of arc, and we are told some information that's very useful. We're told that xy is a diameter of the circle. All right, so let's look at these individually. We are given arc xz first. xz, that is the shortest way to go from x to z, not going around the long way, otherwise it would have been xwz or xyz. So that is a minor arc. It is less than 180 degrees. It's less than half the circle. Then the next one we talk about xyz. The two endpoints are still x and z, but we go through y to get to z. So that is the major arc that corresponds. You'll notice the major arc is always using 3 letters. xwy. xwy. Notice the endpoints are x and y. Those are the diameter. So you might think, oh, that's a major arc. There's 3 letters. But these endpoints are on the diameter, so it makes it a semicircle. We don't call it a major arc. It's a semicircle. Then wxz. They do happen to use 3 letters here. I really don't like how this is written because it is less than 180 degrees. wxz is still a minor arc. It's really just arc WZ. Then WZX goes all the way around through Z to X. So that is a major arc. And then lastly, YZ is less than 180 degrees, so that's a minor arc. Oops, sorry, arc with a C, not a K. All right, let's go ahead and take a look at the rest of our notes. We do have the possibility of what are called congruent arcs. Okay, arcs that are in the same or congruent circles, either they're in the same circle or they're in 2 congruent circles that have the same measure, are called congruent arcs. Adjacent arcs, again, they're going to be in the same circle, but they are arcs with exactly one endpoint in common. They just run up next to each other. Okay? So like in this example of our pie chart here, FA and AB, arc FA and AB would be adjacent arcs. They share endpoint A. Now, arcs that overlap are not considered adjacent. They only have to share exactly one endpoint. All right, so we're going to use the chart on the right to find the measure of each arc. Remember that the measure of an arc is given in degrees. A full circle would be 360 degrees. So even though we're using percentages here, remember that's percentages of 360. So to do these problems, we're going to identify the arc, and we're going to take a percentage of 360. And so we will simply take the decimal form of the percentage and multiply it by 360. So the measure of arc, FA, that's a 14% other category, so we want to do 14% of 360 degrees. So we enter that into the calculator as 0.4 times 360, and we get 50.4 degrees. Okay? The measure of arc AB, that's a 20% wedge of your pie chart. So we want to do 0.20, that's 20%, times 360, which is 72 degrees. And lastly, the measure of arc EF, that's another 14%. We don't have to do that one again. We already did that. That would also be 50.4 degrees. It's just a different 50.4 degrees than arc FA. So the congruent arcs are the ones that have the same angle measures, which means they have the same percentages. So we know that arc EF and FA are congruent. Okay. We also can look and see that there is an 18% volleyball, 18% track and field. So we can also say that arc DC is congruent to arc CB. All right. Now, we've been talking about how to measure arcs this way. Sorry if that was out of the way. You can kind of look at that again. We've been talking about how to measure arcs in degrees, but remember that we are dealing with a circle. The circle itself, when we talk about the central angles, we get a total of 360 degrees, but the circle itself, if I were to measure around the outside like this, that would be a distance measurement or a length measurement. And so we also have the concept of what's called arc length, which is different than arc measure. Okay? The ratio of the length of an arc to the circumference of the circle is equal to the ratio of the degree measured of the arc out of 360. So what we can figure out is that if I take the arc measure out of 360 and multiply that by your circumference, 2 pi r or pi d, instead of 2 pi r, we can get what we call arc length. Arc length is always a linear measure. And so let's look here. Arc measure is measured in degrees. Sorry, I misspelled that. That's 1G. Arc measure is measured in degrees, and arc length is measured in linear units. Okay? So we're going to do a couple of these. We won't do all three. We're going to use this formula. Arc length equals x out of 360, where x is the arc measure in degrees, times 2 pi times the radius. So the arc length of AB is the x of 45 degrees out of 360 times 2 pi times the radius of 3. And then we're going to round that to the nearest hundredth. And so we're going to do some calculations here. Sorry, I didn't realize you couldn't see that. There we go. Copy that down. Pause the video if you need some time to copy that down. All right, I'm going to do the calculations for you and show you what you should get as a final answer. But the first thing you want to do is divide this out. Divide 45 by 360, which gives you the decimal 0.125. Then we multiply it by 2 pi times 3, and this is what we get. About 2.36